Okay, so this example will be a monohybrid cross, but rather than having two parents who are homozygous dominant and homozygous recessive, we're going to have one parent who is heterozygous and one parent who is homozygous recessive. So in this example, I've given an example question. So a heterozygous parent with free earlobes, okay, that's ones that kind of dangle down from your head, have a child with a person with fixed earlobes, which is ones that attach directly to the head. What is the chances of the child they have possessing fixed earlobes? So what we have to do is the same as before. We would have to do a monohybrid cross of this and using a Punnett Square to help you calculate what their children could potentially have. So we start off with our P generation, our parental generation. Okay, and we have one parent who is capital F, small f. Okay, so parent one, their genotype, the alleles they have, is capital F, small f. Now from that, we can figure out their phenotype, even though they've told us in the question. That phenotype is free earlobes. Right, now what that means is that free earlobes is dominant because that person has one capital F, okay, one dominant allele, and they look like they have free earlobes. Okay, that's what their physical appearance is. So in this characteristics, free is dominant. And we use a capital F for this. Small f is fixed, and that is recessive. Now when we cross parent one with parent two, the person with fixed earlobes up here, so parent two, their genotype is two small f's. Okay, so two small f's. That is homozygous recessive. Okay, and because they have two small f's, they have fixed earlobes. Okay, now as a reminder of the terminology from beforehand, capital F and small f, that's two different alleles. When they have two different alleles, they are heterozygous. Okay, one of each type. When they have two of the same, they're called homozygous. And because they have two of the same recessive alleles, they're called homozygous recessive. In this example, what we want to do is find out what their child's genotype could potentially be, and therefore what their child's phenotype, what they look like, could potentially be. Okay, so to figure out the F1, that first generation, okay, what their children are that they have, what we do is we do a Punnett Square. Okay, so like we've done in the previous video. Again, very roughly, and probably going to smudge my pen. As we put one parent at the top, okay, we're just going to put parent one up here. Capital F, small f. Okay, we're going to put parent two over on the side, two small f's. Now again, we're using the capital first, and put that in order. So take this box down, capital F first, small f across. This one, small f down, small f across. This one, capital F down, and then small f across, small f down, small f across. Okay, now what we're going to do now is have a look at what their children could potentially have. So here we have a person who is heterozygous, has one dominant allele and one recessive allele. Okay, we have the same here. So in terms of genotypes, we have two kids, two children, with capital F, small f. And what we also have is two children, potential children, with two small f's, so two potentially homozygous recessive children. Okay, and this is called your genotype ratio. Now what we can do is, because there's 2 to 2, we can simplify that down. We can find a common number to divide into them. So we can divide 2 into 2, and you would get 1 to 1. And that would be your genotype ratio. So for any child that they have, they could potentially have capital F, small f, okay, and be heterozygous, or have 2 small f's and be homozygous recessive. Now what we want to find out is what their phenotype is, what they look like. So looking back at our list, if they have a capital F at any point, they have free earlobes because capital F is dominant. Again, free earlobes is dominant. These have a capital F at one point, so that means that they have free earlobes. These have 2 small letters, 2 small alleles, 2 recessive alleles, and that means that they have to be fixed earlobes. So we have one person or one potential child with fixed earlobes. Now the question is asked, what is the chances of the child they have possessing fixed earlobes? Out of the 2 options, 1 out of the 2, okay, would have fixed earlobes. Therefore that's 50%. So there's a 50% chance of the child having fixed earlobes.